In this video, I'm going to walk you step by step through how to design an SOIC integrated circuit package using DEX. We'll create a standard SOIC device with Gull-Wing leads, and then I'll also show you how to switch that design into a no-lead SOIC package for a more compact footprint and improved thermal performance. On top of that, we'll explore how to add a central thermal pad and even optional thermal vias for heat transfer through the PCB. So let's jump straight in. To begin, we need to create a new SOIC parametric part. Head up to the Home ribbon menu and click the Parametric Part button. As soon as you click it, a dialog window appears containing a large library of configurable package types and device templates. To create the SOIC device, simply click on the SOIC package image. On the right-hand side of the dialog, you'll notice a vertical stack of preview windows. These previews are extremely useful because they show you exactly what is being generated in real time. At the top, you'll see the schematic symbol preview. Beneath that is the PCB footprint or LAN pattern preview. And finally, at the bottom, you'll see a fully generated 3D model of the package. One of the really impressive things here is that DEX automatically creates the 3D model for you. There's no need to download models from the internet, and you don't have to spend time manually building them in a separate 3D CAD application. Now double-click the SOIC package to open it. The dialog closes and the main application window opens. You'll immediately see the PCB footprint displayed in the central workspace. On the left, there's a tab containing the schematic symbol, and on the right, another tab showing the generated 3D model. Next, go up to the Panels menu and click the PCB in 3D option. This splits the workspace into two synchronized viewports. On the left, you'll see the PCB footprint editor, and on the right, the interactive 3D model viewer. If the Part Builder panel is not already visible on the left side of the footprint viewport, simply open the Panels ribbon menu and click the Part Builder button. Now we can start customizing the package parameters. On the left-hand side, you'll find the Parameters section. This is where all the core settings that define the SOIC package are located. Starting at the top, you can change the number of pads. This determines how many pins the package will contain and how many rows there are. Directly below that is the pitch setting. The pitch defines the spacing between individual pads or pins, which is one of the most critical dimensions in any surface mount package. The pitch setting controls manage the pitch, outer and inner, spacing between the pads and columns. Further down, you'll encounter the pad name prefix group, where you can add text prefixes for the pads in the left column and pads in the right column. These controls give you precise control over the overall package geometry. Next, we come to the lead type selection area. Here you can choose between several different lead styles depending on the package you want to create. The available options include Gull-Wing leads, Leadless packages, J-leads, and straight leads. For a traditional SOIC package, Gull-Wing leads are the standard choice. However, if you want a smaller footprint and improved thermal characteristics, you can switch to the leadless option to create a no-lead SOIC style package. There's also an option to add fiducials. Fiducials are alignment markers commonly used during automated PCB assembly. Pick-and-place machines use these marks to accurately align components before soldering them onto the board. Although fiducials are not always required for every design, they can be extremely useful in high-precision manufacturing environments. Now let's look at one of the most useful features, the central thermal pad. At the bottom of the parameter panel, you'll find controls that allow you to add a central pad to the package. Central pads are commonly used to improve heat dissipation by transferring thermal energy directly into the PCB. To add one, simply enable the Add Central Pad checkbox. As soon as you do, a new pad is automatically inserted in the center of the package between the columns of pads. You can then adjust the clearance between the central pad and the surrounding pads to suit your manufacturing and thermal requirements. If additional cooling is needed, you can also enable thermal vias. Thermal vias allow heat to pass through the PCB from the top side of the board to the bottom side or internal copper layers, dramatically improving thermal performance for high-power devices. When thermal vias are enabled, the central pad automatically changes from a standard SMT pad into a plated through-hole style pad because the vias need electrical and thermal connectivity between layers. And if you later disable the thermal vias option, the pad automatically reverts back to a surface mount pad again. An additional advantage of using a central plated through thermal pad is that you can route PCB tracks on both the top, inner, and bottom layers directly to that pad if required. And that's essentially the full workflow for creating and customizing an SOIC package inside DEX. I highly recommend experimenting with the different package settings yourself. Creating parametric components like this is not only incredibly useful for PCB design workflows, but it's also a great way to better understand package geometry, manufacturing constraints, and thermal management techniques. Thanks for watching, and I'll see you in the next video.